So right now we're going to take a look at subtracting integers. Or is it? Let's see what I mean by that. Okay, so here's a number line similar to one that we looked at the last time on adding integers. And we know that we start at 0. And we know that when we add integers, we go in the direction of the sign. Okay, so if that is the case, there's one possible equation that I can get from this. Starting at 0, I add a positive 6. And to that, I go next in the negative direction, negative 5 units to get positive 1. That is one possible equation from this number line. The other possible equation is, let's take a look at it. If we weren't thinking about integers at all, we're just thinking about adding and subtracting, well, we might look at it and say, oh, that is 6 minus 5, and that equals 1. Okay? Not a bad equation either. Let's add our positive signs, even though we don't need to write them. Anytime we see a number without a sign attached, we assume that it is a positive, but we're gonna for this exercise we're gonna put them on there. So I have two different equations that give me the same result. Positive 6 plus a negative 5 equal to a positive 1, and a positive 6 minus a positive 5 also equal to a positive 1. From here, we can make it, since they both have the same value, then we could actually set these two equations equal to one another. So we could say that a positive 6 minus a positive 5 is the same as positive 6 plus a negative 5. And now what differences do we see between these two expressions on each side of the equal sign? We know that they both give us a value of positive 1. But this one here, our operation is subtraction, and this is addition. So instead of subtraction, we could call our operation addition. And here's a positive 5, and then over here we're adding a negative 5. And we should know that positive 5 and negative 5 are opposites. They have the same distance from 0 and opposite directions of 0. So what we really could say is that subtraction is addition, where we add the opposite. Subtraction is adding the opposite. Okay, so instead of adding, we're subtracting. So subtraction is the same as adding the opposite. Let's see how that works out. So let's do several examples. And what we'll do, we'll take our subtraction expressions and rewrite them as addition expressions and see that we get the same answer, or see what our answer is. So the first one is obvious. 9 minus 5. We know that is positive 4. But let's see what happens when we change it from a subtraction expression to an addition expression. Remember, subtraction is just adding the opposite. So we still start at our positive 9. And instead of subtracting, we're going to add. And instead of subtracting a positive 5, we're going to add a negative 5. So positive 9 plus negative 5. Signs are different. So we subtract the absolute values. 9 minus 5 is 4. And 9 is further away from 0 than negative 5. So it is a positive 4, which is the exact answer we would have expected. Okay, so subtracting a positive 5 is the same as adding a negative 5. Let's try the next example. Positive 4 minus positive 8. We rewrite the expression. We start at positive 4. We're going to add to it the opposite of positive 8, which is a negative 8. Again, the signs are different. So we subtract, we find the difference between the absolute values. 8 minus 4 is 4. And since negative 8 is further from 0, our answer is negative 4. Now imagine real quick the number line, what that will look like. Because when we subtract, when you subtract a positive integer, we always went to the left on the number line. In our first example, remember, we were subtracting 5 and we went 5 units to the left. So here we would subtract 8. So we would go 8 units to the left. And 4 of them get us to here, and 4 more units to the left bring us to negative 4. So that does work out even on the number line. Back to our examples, and now we're just going to stick to the rule for adding integers. So first thing we do is take our expression negative 6 minus positive 7. We're going to rewrite it as addition. Negative 6, change our subtraction to addition, and take the opposite of positive 7, negative 7. So negative 6 plus negative 7. Now our signs are the same. So a negative plus a negative gets us a negative, and 6 plus 7 is 13. So negative 6 minus positive 7 is the same as negative 13. Another example, negative 3 minus negative 9. Negative 3, we're going to rewrite it as plus, and the opposite of negative 9, a positive 9. Negative 3 plus a positive 9. So our signs are different. Find the difference. 9 minus 3 is 6. And since positive 9 is further away, we get a positive 6. Not too bad, right? Don't let the negatives fool you. Okay, for example, let's try a different example to the side for a second. Let's say we have negative 10 minus negative 5. Well, we have 10 of anything that's negative, and you take away 5 of those things, negative, you're going to be left with 5 negative, which is the same as saying negative 10 plus the opposite of negative 5, positive 5. Signs are different. Find their difference, which is 5, and the number further from 0 is negative 10, so negative 5. So these two expressions right here have the same value. So once again, subtraction is just the same as adding the opposite. Okay, so one last example back over here that I got for you is a positive 5 minus a negative 7. Doesn't change. We're still going to take our positive 5, take our subtraction, change it to addition. Instead of adding a subtracting a negative 7, we're going to add a positive 7. And 5 plus 7 equals 12. So this is the hardest one, I think, for students to understand, is how can I subtract something and my answer get larger? Remember the number line. Remember when we subtracted integers, we went the direction opposite the sign. Go back to this one here. We were subtracting a positive 8 originally. Go to the original one. We subtracted positive 8, so we went to the left. We went to the negative direction. So it only makes sense that when you subtract a negative integer, you're going to go right on the number line. So 4, 5, 6, 7, 8, 9, 10. So if I start here, so remember then my zeros here, I come to my positive 5 and subtracting a negative 7. Well, to subtract a positive, I went to the negative direction. So it makes sense that when you subtract a negative, you would go in the positive direction, 7 units, and you would end up at positive 12. Whichever you decide to do, you can use number lines if you want, but I think it's easier just to take my expression, rewrite it as addition, and add the opposites of the second addend. And notice that the first addend here, these all stay the same. They do not change. You're taking the opposite of the second addends. So your operation changes from subtraction to addition, and you take the opposite of the second addend.